I saw this thumbnail in my feed recently, and I decided let's take it on as a challenge. So Cybermath's original video was there. Check it out. And I haven't seen it yet, but here's my approach. So what he's challenging us to do is find a solution to e to the x equals k times x. What k will make this work? Now, let's put this on the Cartesian coordinate system. So here's your e to the x. Okay, that's e to the x. And k times x, okay, is like, it's a whole family of functions. I mean, lots of things are k times x. It's just a straight line going through the origin, which I can't draw. That's not the line that we want. There's also lines that are going to go like this, and like this, and like this. We're not interested in any of those. What we want is the line that goes through the origin and just kisses e to the x and then heads off on its own forever. So that's what we are looking for. And this is a huge mess right here. Well, we want to find that point, really, basically. Let's clear the screen and do this again. So really, we're looking for a zero. We're looking for a zero of this function. E to the x minus kx equals 0. Okay? So let's look at this without all the extra lines, and just this one here. Okay? And let's talk about this one. Y equals kx. So k is the slope of the straight line. And what is the slope of e to the x right at this point? Well, that's what e to the x is it's that exponential function with its own derivative. So the slope is e to the x. So this line is just it's y equals x times e to the x. And when we see x times e to the x, we think, because we're so clever, Lambert W function, right? Yeah. But guess what? We don't care. We don't need, it would be cool if we could use the Lambert W function thingy, right? Everything that we know about it. But we don't need to. Because look at this. Let's replace this e to the x minus, so this is x times e to the x, and that all equals 0. Okay. Now let's just factor out the e to the x. E to the x, 1 minus, that's a minus sign, x, and that equals 0. So when is that 0? Well, when x equals 1. So x equals 1. So this point right here is 1 comma e to the 1, which is e. That's the point of the point. Now, there is kind of another solution, because we didn't look at this factor, right? And when e to the x, this is lagging, equals 0, okay? I'm just going to say it's never going to equal 0, okay? But it approaches 0 as x approaches negative infinity, right? So way down here, so the x-axis is kind of like a tangent too, but it's not really a tangent because it never touches. So really it's the kind of tangent that never touches, which is an asymptote. So there's my solution somewhere on the screen if you can find it. And check out the Cybermath video. And I'm going to watch it too, because I haven't seen it.